Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 2367, number of arithmetic triplets. You are given a zero indexed, strictly increasing integer array nums and a positive integer difference. A triplet ijk is an arithmetic triplet if following conditions are met. I is less than j is less than k. Nums of j minus nums of I is equal to difference. Nums of k minus nums of j is equal to difference. Return the number of unique arithmetic triplets. So they are asking us to find three numbers whose satisfies these conditions. Their indices should not be equal and I is less than j is less than k. Fine. Now their each difference should be equal to the difference value they have given. So see here in this example 0, 1, 4, 6, 7, 10. Now the difference is 3. What are the possible unique triplets we can form from this? See here 1, 4 gives the difference of 3 and 4, 7 gives the difference of 3. So it is one triplet. Now what is another triplet? See here 7, 10 gives a difference of 3 and 4, 7 gives a difference of 3. So this can be another triplet 4, 7, 10, right? So how to approach this problem? Let me write this 0, 1, 4, 6, 7, 10. 0, 1, 4, 6, 10. Now they have given the target as the difference as 3. Then the triplets are 1, 4, 7 and another is 4, 7, 10. So how to approach this problem? What is a simple brute force solution? We know that the brute force solution is like just iterate I from 0 to n, right? Then j from I plus 1 to n, then k from j plus 1 to n. Then we have got all three combinations like the 0 with this 1, we have got all this rightmost combos. Then 0 with this 4, we will get all this rightmost combos. 0 with this 6, we will get all this rightmost combos. Okay, this is the meaning of this loop. Fine. Now after this loop, we can check the condition like is nums of j minus nums of I is equal to difference and nums of k minus nums of j is also equal to difference, right? That's what the condition I have given, right? See here, this is the condition, right? So I will put that condition and check whether this condition is equal. Then I will increase my result variable by 1. Then I will return. So this is my simple brute force. Approach. This is approach number 1, right? But how can we optimize it? Again, I will write the example 0, 1, 3, 4. Sorry, there is no 3. 0, 1, 4, 6, 7, 10, right? And they will give the differences, any integer values. Now listen carefully. For this 0, I can say the difference of 3 will be minus 3, 0 and 3 will be the triplets. For this 1, I can say 1 minus 3 is minus 2 and 1 plus 3 is 4. This is a triplet for 1. And for 4, I can say, for this 4, I can say 4 minus 3 is 1, 4 plus 3 is 7. This can be a triplet. Now for the 6, I can say the triplet may be 6 minus 3, which is 3, and 6, and 6 plus 3, 9. Now for the 7, I can say 7 minus 3, 4, 7, 7 plus 3, 10. For this 10, I can say 10 minus 3, which is equal to 7, 10, 10 plus 3, 13. These can be my all possible triplets in this array, all possible triplets in this array, because they have said that nums of j minus nums of I should be difference, right? Then take this to here and bring this to here. Now nums of j is equal to minus different is equal to nums of I, right? Nums of I. Now they have given another condition, nums of k minus nums of j is equal to difference, right? Now again bring this here, nums of k minus difference is equal to nums of j, right? So from this two equation I can conclude that for every element nums of j, if I minus different, I will get nums of I. Yes, for every nums of j, if I plus difference, I will get nums of k. Because this equation tells that, right? Because if this difference go here, this difference goes here, nums of k is equal to nums of j plus different, right? So I can say that when I am adding the different to my nums of j, I get nums of k. When I will minus the different, when I minus the different with nums of j, I will get nums of I, right? So I can write by combining this two. I'll write here with different color. See here, I can conclude that difference, nums of j minus difference is first triplet element. Now the next triplet element is nums of j. Then next triplet element is nums of j plus difference. So can I come to this formula, right? So this is the triplet. See here, that's what I have written here. Now check with the formula, you will understand this. We have written this line, right? Now we have got the intuition. But how to approach this problem? In an optimal way. See here in the question they have given a hint. See here in the question they have given a hint that strictly increasing means, what is that? It is in sorted order, right? It is in sorted order, but there is no duplicate element also. So I can use binary search. Okay, fine. I have told you we can use binary search, but how to implement that binary search? See here, we want only this nums of j. Okay, this nums of j. By using this nums of j, can I find this nums of j minus difference and this nums of j plus difference, right? So I will iterate I from 0 to n. Then I will check for a binary search for nums of this I. Here I have used I. If I can use j minus different, right? Also, I want to check for binary search of nums of j plus difference, right? If this both condition fail, this both condition passed. If this both condition passed, then I can increase my result by 1, return result, right? So what is the time complexity of this solution? What is the time complexity of this solution? It is, first of all, time complexity is O of, we are iterating through every element, right? See here, we are iterating through every elements up to n, so it is n, and we are going to check for binary search in that n elements, so log n, and another binary search for n elements, so another log n, right? So this can be written as n into log n square, right? And that can be written as O of n into 2 log n. We don't take this constant, right? So the overall answer is n log n, right? So the approach is n log n time complexity. What is space complexity? It is O of 1, because we haven't used any space here, right? See here, the brute force approach is what? The time complexity is O of n cube. Space complexity is O of 1, because we haven't used any extra space in brute force, right? Because we have used this only this 3 for loop, that's why the time complexity is O of n cube, right? So this is the approach here. We can also use a set. We can also use a set instead of this binary search approach. We can use set instead of this binary search approach, but still the time complexity for set is n log n, but it requires a space of n to store every element in it. Okay, other than that, the same formula. First, you have to iterate to every element, then check whether there exist nums of j minus difference and nums of j plus difference, right? So these are the two values you have to check in the set data structure. Same binary search, but still you can also use set, but it is not efficient like binary search, right? So binary search is the second approach, and the brute force is the first approach. This is the first approach, right? Let me code it up. Just see here. See here, this is the brute force approach, right? This is the brute force approach. Let me run it. See here, as I told in the intuition, the same code I have used, but still here I have used -2, here I have used -1, because after I pointer, 2 pointers j and k will be placed next to the I. So we don't want to iterate to these 2 last elements, right? So that's why I have used -2 here and -1 here, because k will be there after the j pointer. So I don't want to iterate there, because the condition of k also will be false when I put j plus 1 and length of nums here, right? So I have used a simple reduction of iterations. Now, if the condition satisfy, I will increase the c value and I will return the c value. Let me submit it. Yes, submitted successfully. This is the brute force approach. Now, entering to the binary search approach. First of all, I have implemented a binary search approach separately here. A binary search for checking whether a number or an element is present in that array or not. Then I am iterating through every single elements in an array and doing a binary search for that formula. That is for nums of j. If I want to calculate nums of I want to use nums of j minus difference formula, and to calculate nums of k, I have to use nums of j plus k formula, right? That is plus difference formula, right? So that's what I have used here. and I have called the binary search function. If this both functions are true, then I will increase my result variable. Now I will return the result. Let me run this. What happened? Network is slow, I think. Yes, submitted, right? So this is the optimal approach. First of all, you want to know that we want to implement everything in the brute force, then see what are the parameters they have asked and what are the parameters we can get into some relations between them, right? We want to get some relation between those parameters, then come up with some formulas and some approaches, then solve it, right? So thank you.